Okay, so what we have seen in the previous lecture, I'll quickly recall and then I'll go ahead. So we have seen order and degree of a differential equation. Order of a differential equation is the highest number of times the dependent variable is differentiated in the differential equation. That is called the order. And degree of differential equation is the power of highest order derivative occurring in the differential equation when it is free from fractions and radicals. Okay, so we have also seen some of the examples on order and degree. After that, what we started was the solution. So we were studying one example in which we had this d2y by dx square plus y is equal to 0. And we came to a conclusion that the solution of a differential equation is the relation between the dependent variable and the independent variable satisfying the differential equation. Okay, so we saw that y equal to sine x. Please mute yourself, whoever it is. Y equal to sine x, y equal to Mohan. Can you mute yourself? Y equal to sine x was the solution. Y is equal to cos x was the solution. Then y equal to sine x plus cos x was also the solution. And so there are infinitely many solutions to a particular differential equation. And we combine all those solutions in this form. Y is equal to c1 cos x plus c2 sin x. So this type of solution where you have arbitrary constants c1 and c2. Why do you call it arbitrary constant? Is because you put any values of c1 and c2, you will get solution of this differential equation. So number of arbitrary constants is equal to the order of differential equation. So if this condition is satisfied, then the solution is called general solution. So our task is to find out the general solution. And if there are some conditions given, then I will go for the particular solution. Look, I don't want any disturbances or I will mute everyone at the same time. And you won't be able to unmute yourself later. So such type of solution is called the general solution. Remember the definition, the solution in which number of arbitrary constants is equal to the order of differential equation. And the other type is the particular solution. The solution obtained by assigning particular values to the arbitrary constant is called the particular solution. In the above cases, all these three are the particular solutions. These are particular and this solution is general. That's all about solutions of a differential equation. So we need to understand one thing. We are doing it two ways. Like we have a differential equation and I can find solution of the differential equation. Also, if I have a solution of a differential equation, I should be able to find the differential equation corresponding to it. So we need to work two ways. So if I'm given a function, I should be able to find out the differential equation for that function. If I am given a differential equation, I should be able to find the solution. So both ways we need to study. Okay, and just a logical thing, can you form a differential equation for the function y is equal to, say, e to the power x, c1 e to the power x? Can you make a differential equation from this y is equal to c1 e to the power x? Anyone, how can you do it? Any idea that you have, we could discuss that idea and we could come to some conclusion. Y is equal to c1 e to the power x seems like a general solution for some differential equation. I need to understand that differential equation, which what that differential equation is. No one?
So we have to
Sir,
eliminate
dy
the
by dx
constant.
minus y is equals to 0.
Dy by dx minus
Minus y.
is equal to 0. And why is it so?
Sir, because if you differentiate and then subtract, the answer comes 0.
Okay. So what you're doing is you are differentiating and you are observing some differential equation which would satisfy this. Someone said eliminating. Who was it? Please repeat your statement.
So there is one arbitrary constant. So we have to differentiate it one time, sir.
Yes. And later what we have to do? So dy by dx is equal to c1 derivative of e to the power x is e to the power x. But what is c1 e to the power x? The value of c1 e to the power x is y. Okay. So from this equation, what I can write is dy by dx minus y is equal to 0. And this is the same thing that Sumit said. So dy by dx minus y is equal to 0 is the differential equation for y is equal to c1 e to the power x. So what I have done here, I have differentiated the given function one time, and then I have eliminated the arbitrary constant. Okay, this arbitrary constant is eliminated. Now I'll write another equation. Oh, sorry. Y is equal to y is equal to c1 log of 2x plus 3 plus c2 cos. Now what you can do? So
Differentiate twice
differentiate it twice. Why?
because there are two constants, arbitrary constants.
Exactly. So I will have to differentiate it twice, and then I have to eliminate the arbitrary constant. So This is the complete procedure, and why you're differentiating it here two times is because there is a definition of the general solution. What it says is the number of arbitrary constants has to be equal to the order of differential equation. So by differentiating this y two times, what I do is I make the order of differential equation as 2, and that is the complete procedure. So I will give the new heading and write down the procedure. If you are maintaining your notebook,
Sir,
that will be really great. So maintain a notebook and please write down the notes whenever I'm teaching it here. Yes, someone,
sir, is this meeting for division 16 or division 18?
both. So formation,
सर आप स्क्रीन शेयर कर रहे हो क्या?
of course.
हाँ, ठीक है सर. सर दिखाई ना दे रही इसलिए.
दिखाई नहीं दे रही. Is there anyone else who is not able to see the screen?
No, sir, we can see.
Okay sir, I will meet you.
Yes. So I will start with formation of a differential equation. So what is the method?
Hey, Papa.
Method is first one, differentiate. The given function as many times the number of arbitrary constants. So whenever we see any function, our first task is to differentiate it as many times the number of constants are appearing. Say if it is appearing 2 times, then differentiate it 2 times. If there are 3 arbitrary constants, differentiate it 3 times, and so on. Uh, so number of arbitrary constant or the arbitrary constant, whatever are there, those will be mentioned in the question itself. And then the next task is eliminate arbitrary constants to form a differential equation. To form a differential equation. Okay, so any differential equation may not consider, I mean, it should not have the arbitrary constant. That is the complete procedure. So let's start with some of the examples. Example. First one. Obtain the differential equation. Obtain the differential equation whose general solution is y is equal to a e to the power minus 9t cos of 3t plus b, where a and b are arbitrary constants. Okay. So there are two arbitrary constants. I will have to differentiate it 2 times, and I will have to eliminate those a and b from the function.
Sir, what is that a e raised to 9t minus 9t?
Yes.
Okay.
So y is equal to a e to the power minus 9 t cos of, in bracket, 3t plus b. So I'll differentiate it once. So that becomes dy by dt. The independent variable here is t, so I am differentiating with respect to t. Differentiating with respect to t. So what I will get is a minus 9 e to the power minus 9 t cos of 3t plus b plus a e to the power minus 9 t derivative of cos minus sine, and that by chain rule you will get 3 sine of 3t plus b. Look, in this forming of differential equation, you can always simplify your calculations by resubstituting the values. So a to the power minus 90 cos of 3t plus b, this is nothing but y. So we'll put that value here, dy by dt. Minus 9 will come outside, and you have a cos 3t plus b, which is nothing but y, plus minus 3a minus 3a e to the power minus 9t sine of 3t plus b. Now we can differentiate this once again, differentiating with respect to t. So we'll get d2y by dt square is equal to minus 9 dy by dt minus 3 outside. Then apply the chain rule over here. So what we will get is a minus 9 e to the power minus 9 t sine of 3t plus b plus a e to the power minus 9 t in bracket sine of 3t plus b, the derivative is 3 cos of 3t plus b. How can we eliminate now?
So from third equation, we can substitute the value of this term.
So let me name this. This is the equation number 1, equation number 2.
So from second now, from
Yes.
second we can substitute.
So d2y by dt square plus 9 dy by dt is equal to minus 3 into minus 9. So totally that will become plus 27 actually. So plus 27,
Sir, 3 will go now.
where it will go?
Sir, in
Plus-
second equation, 3 is also there now, so we will substitute the value of 3 also.
Yes, you can do that. Okay, let's do it here itself. So that will become 3a to the power minus 90 sine of 3t plus b. So minus 3 and minus 9 at least I should write. So minus 9 and then you will get minus 3 a to the power minus 90 sine of 3t plus b, and that is dy by dt plus 9y. Right, Adarsh?
Yes, sir.
And then opening the bracket and this minus 3 and this 3, that will totally become minus 9, and you have a to the power minus 90 cos of 3t plus b, which is nothing but y. And this can be simplified further, and I'll write it down, the differential equation simplified one over here. So d2 minus plus 9 dy by dt minus 9 dy by dt on the right hand side. So totally that will become 18 d2y by dt square plus 18 dy by dt, and then you have minus 81 minus 9 minus 90 will become plus 90 y equal to 0. Clear? If you have any difficulties, you can ask, or I will go ahead. Okay. Second example. Y is equal to 4 x minus a whole square. Yes. Who can tell me the final solution? You have 2 minutes. It's a very easy example.
Sir, dy by dx minus 4 root y equal to 0.
No, actually. Where is Siddhi?
Yes, sir.
Yes. Can you tell me the differential equation for this?
Just a minute, sir.
Sir, is it dy by
dy
dx
by
minus 4
dt
root y?
equals to 4 root y.
dy by dx is equal to
4 root y.
4 root y.
yes, exactly.
Sir, I also said that, sir. But I take sir right hand side 0.
You said right
So
hand
dy
side
by
0,
dx
but
minus 4 root y equal to 0.
okay, maybe I didn't understood it properly then. So taking the derivative dy by dx is equal to 8 into x minus a, taking the square dy by dx whole square is equal to 4 square 2 square x minus a square. This term is nothing but y. So dy by dx whole square is equal to 16y. Third. Y is equal to ax square plus bx cube. So let's take the derivative. Dy by dx is equal to 2ax plus 3bx square d2y by dx square, that will be 2a plus 6b into x. So how can we eliminate the arbitrary constant? You give the idea, no need to solve it. If you have any idea, anyone.
Sir, can we put that first 2a value equals to d square y by dx square minus 6bx in second equation?
Yes, exactly. That will work. You can put the value of 2a in
2a.
terms
In
2a,
that equation, right?
and then you will get the value of b.
B.
And then from b, we can also get the value for a. And both of them we can put it in the first equation.
Yes, yes.
So equation number 1. That is one way, or you can directly solve linear equation second and third. You can solve 2 and 3 linearly, and then we will get the values of a and b. So I'll go with the method that you spoke about. From 2 and 3 or 3, we get 2a is equal to d2y by dx square minus 6bx. Put in equation number 2. So what we get is dy by dx is equal to d2y by dx square minus 6bx plus into x plus 3bx square. So this could be solved. Can you tell me the value of b?
Then x d2y by dx square minus dy by dx upon 3x square.
X d2y by dx square आगे
minus dy by dx
minus dy by dx
and whole divided by 3x square.
whole divided by 3. Others, please check whether it is correct or not.
Yes, sir.
Yes, sir. It's
Then let's get the value of b. Oh, sorry, a. So 2a is equal to d2y by dx square minus 6x in bracket the value of b, x into d2y by dx square minus dy by dx upon 3x square. So 3, 2, 1x will get cancelled out and then multiply. Okay, the value of a will become 1 by 2 d2y by dx square. This 2 will get cancelled out minus 1 by x. So 1x from the first term will also get cancelled out. So cancelled out x, so minus d2y by dx square plus 1 by x dy by dx. Okay, so you can put these two values and find the final solution. Please tell me what is the differential equation you get after substituting this. Hence, we get y is equal to you won't get, I think, y equal to the solution is x square d2y by dx square minus 4x dy by dx plus 6y equal to 0. For solving this, there is another method which can be used here, that is determinant method. In your LADC course, you have seen that if you have 3 equations in 2 variables, so how many solutions you will get?
Infinite.
Infinite. So you can see that there are this a and b are unknowns over here. So if you consider it and if you try to solve it, we will get infinitely many solutions. So in that case, what I will have to do is I will have to collect the coefficient x square, x cube, y or minus y, whatever methodology you are using. Then the second one 2x, 3x square, dy by dx. In the last one, you will have 2 6x d2y by dx square. We know that if there are infinitely many solutions, determinant has to be 0. You just solve this determinant and you will get a differential equation. That is another way. But of course, this one is easier, so I didn't introduce it earlier. Anyways, let's go ahead now. There's just one last type of example which we need to discuss, and then we can go ahead with the new topic. The next question is, form the differential equation of circles which touch the y-axis. Touch the y-axis at the origin. At the origin, and the center lies on x-axis. Identify the circles first of all which are satisfying this condition. So you have the center on x-axis and the circle is touching y-axis. First circle, second circle, so this type of circles are going to be there. Can you form the equation?
So x minus h whole square plus y square equals to r square.
X minus
H whole square plus y square equals to r square.
Okay.
Yes, sir.
So the 2-point form or the center and radius form is x minus a whole square plus y minus b whole square equal to r square. And where a comma b represents the center of the circle, and center, as you can see, it is on the x-axis always. So y coordinate will always be 0, so that is, as he said, x minus
Sir,
a.
in place of r square, we have to write y square, no?
Yes, that change we will do is equal to r square. Now, the coordinate, whatever it is, that the same thing will be going to be the distance from the origin as well as the radius. That's why this will become x minus a whole square plus y square equal to a square. So totally how many arbitrary constants are there? Only one arbitrary constant. One arbitrary constant. Now you can either simplify or you can directly take the derivative. It is of course up to you. I would like to simplify. So that will become x square plus y square is equal to 2ax if you simplify this. A square on the both side will get cancelled out, minus 2ax from the first term. On the right hand side it will become 2a. Now differentiating with respect to x. And so we'll have 2x plus 2y dy by dx is equal to 2a. Equation number 1 This is equation number 2. 2 will get cancelled out from the both the sides, substituting 2 and 1. Substituting 2 in 1, we get x square plus y square is equal to 2a. I should put the value directly, 2x plus 2y dy by dx into x. This is the differential equation for this family of curves. Done. We'll try to solve one example where, should I go to the next page or you are writing this?
Writing, sir.
Okay. Try to solve this example. Form the differential equation. Form the differential equation of all circles but Utkarsh, mute yourself. Having their centers on straight line y is equal to 5 and touching x-axis. First of all, form the equation for this family, and then yes, what is the equation of this family? So draw the diagram if you are not able to understand this. X-axis, y-axis, centers on the straight line y equal to 5. Y equal to 5 will be a straight line. This is y equal to 5. So you have centers on this and touching the x-axis, it should be, sorry, touching the x-axis. So let's make the first circle which is touching x-axis. What is the radius?
5.
5, sir.
5.
So the equation will be x minus h whole bracket square plus y minus 5 whole bracket square is equal to 25.
Yes, sir.
y minus 5 bracket square equal to 25. Yes, exactly. Solve it, form the differential equation and tell me the final solution.
Sir, can you tell this how the equation is correct?
Yes,
Sir,
Rishikesh.
sir, it would be x plus y into dy by dx equals to 2h.
Just a minute. Rishikesh, you have some problem?
Yes, sir. Sir, I can't understand that how the equation come.
How the equation?
Come. That x minus x.
Do you know equation of circle? What is the equation of circle? Can you tell me? With center and radius. If the center of a circle is a comma b and radius is r, what will be the equation?
What, sir?
Equation of circle when center is AB and radius is R. Okay. Anyways, so the equation of circle when center is A comma B and radius is R is given by x minus A whole square plus y minus B whole square equal to R square. This is the center and this is radius. So from the diagram, it is clear that if you take any of the circle, the center will have y coefficient as 5, and this can be anything. And the radius of it from the x-axis, this distance will always be 5 units, since y coordinate is 5. So what they did is, they have put the y coordinate as 5, left the x coordinate of the circle as the arbitrary constant, and they have put the radius as 5. That is how it is done. Yes, there was something else from some part, I guess.
Yes, yes, sir. X plus y into dy by dx equals to 2h. Is it correct?
X minus 5.
So no, sir. X plus y into dy by dx.
X plus 1. Bracket complete.
No, sir. X plus, I'm telling y. X plus y into dy by dx.
Dy by dx.
So that y into dy by dx is different term. So that x is different and y
Okay.
into dy by dx is different.
Okay. X plus y into dy by
dy
dx.
by dx equals to 2h. Is it correct?
No, I guess. No.
Equals to
Anyway,
2h, sir. 2h.
it should be eliminated, or you cannot declare differential equation. In a differential equation, there should be.
Yes, sir. Okay. Understood. So, okay.
So the final answer is y square minus 10y plus dy by dx whole bracket square into 5 minus y whole bracket square.
Just a minute. Let me write it down. Yes. Y square minus 10y
plus dy by dx whole square
dy by dx whole square
into 5 minus y whole square
into 5
minus y
whole square
equals to 0.
Okay. I think this is the same thing as y minus 5 whole square 1 plus dy by dx whole square is equal to 5 square. I guess yes.
Yes, sir. I will.
Yes, it is correct. So how we get this? You just differentiate and eliminate the arbitrary constant. So if, this can be further simplified. Remember that this is the same thing that we done in the previous one. And 2 times x minus h plus 2y dy by dx is equal to 10 into dy by dx. Then you can find the value of x minus h from this 2, 2, and this will become 5. So x minus h is equal to 5 y plus 5 dy by dx. 5 minus y. This will be 5 minus y dy by dx. This value you can substitute it here and you should get this equation.
Sir, in the solution, we should have 1 plus 2 dy by dx whole square.
1 plus 2?
In the bracket, we should have 1 plus 2 into dy by dx whole square.
Maybe I actually don't know. This is written last year. There can be some error in this. But I don't think so. It should be. Should I solve it here? Anyway, so 5 minus y whole square dy by dx whole square plus y minus 5 whole square is equal to 25 or simply 5 square. So I can
Sir, there is
y,
-1 there.
y minus 5 whole square I can take common, and in bracket I will get 1 plus dy by dx whole square is equal to
Sir,
5 square.
1 minus, right?
Where?
dy by dx whole square minus 1.
No,
Because
no.
it is 5 minus y whole square and
But
But
it is a square
y
form,
minus y
no?
minus
Square.
5 whole square is equal to 5 minus y whole square.
The square is always a positive number.
So if you take minus sign common from the right hand side, say minus of y minus 5.
yes,
This
sir,
is
I got my mistake. Yes.
okay. So that's it. We have ended with formation of differential equation. In the next lecture, we'll start with solutions of differential equation. One way we have done, the other way we have to do it now. I will share the link now. Should I stop the sharing of the screen? Or yes?
Yes, sir.
No. Put your name. Sorry, not name. Just the roll number you have to put.
In the chat box, sir.
Wait. I'll give you the link. On that link, you can fill it. Don't put it in. Just like the previous one, we are going to follow the same procedure.
Google
Go to
Forms.
Yes. Go to the link, enter your number, mark your attendance.